Alright, here we have another example. Use the second derivative test to find the local maximum and the local minimum of this function. Um, since we are going to take the derivative first, so let me rewrite the function so it will be easy for me to take the derivative. Okay. And also, we wanna look at what is the domain of this function. For this function, since we have x in the denominator, so x cannot be 0. Therefore, the domain will be any number except 0. Okay. Okay. After we finish this, let's start taking the derivative. So the derivative is 1 minus 36x to the power of negative 2. And that will be 1 minus 36 over x squared, which equals which equals x squared over x squared minus 36 over x squared, which is x squared minus 36 over x squared. Now the next thing is I want to find the critical points of the function. So we have two places where we can find the critical points. One place is when the first derivative equals 0. So when the first derivative equals 0, that means the numerator gonna be equal to 0. So x squared minus 36 equals 0. That means x squared equals 36. So x equals positive 6 and negative 6, right? Because both of them are in the domain of the function, so both of them are critical points. The second place to find the critical point is when the derivative does not exist. For this derivative, we can see if x squared is 0, which means if x equals 0, then the derivative does not exist. However, because 0 is not in the domain of the original function, therefore, even though the derivative does not exist at 0, but this is not a critical point. 0 is not a critical point. Okay. So we have only two critical points. One is 6, another one is negative 6. Okay, now next, using the second derivative test to determine the maximum and minimum, we need to take the derivative again so we can have the second derivative. So that is, we continue on this part. The derivative of 1 is 0, and the derivative of the second piece is negative 2 times 36 to the power of negative 3. So the second derivative is 72 times 72 times x to the power of negative 3. Okay. Now at x equals 6, the second derivative is 72 over 6 to the third, which is a positive. So since it's positive, the function has a local minimum at x equals 6. And at x equals -6, the second derivative is 72 over -6 to the third. That's negative. Therefore, the function has a local maximum at x equals -6. Then, because the question asks for the coordinate of that point, so the maximum, for the maximum, the x coordinate is -6. And to find the y coordinate, we plug the -6 into our original function. So that would be f of -6, which is -6 minus 6 is -12. And the minimum, it occurs when x equals 6. And the minimum value is f of 6. So that is 6 plus 36 over 6, which is 12. Okay. Let's take a look at the graph of this function. All right. So we can see the function has a local a maximum when x equals -6, and the maximum value is -12. And the function has a local minimum when x equals 6, and the minimum value is 12.